All right, if you're an electrician or an apprentice in Australia or New Zealand, listen up. These are the mandatory safety checks you absolutely need to have down pat. We're going to break down the essential tests required by the AS/NZS 3000 wiring rules for every single new installation. Before any Sparky even thinks about flipping that main switch, this is the one question they have to answer. And it's not a guess, it's a certainty they have to prove. So, how do you prove it? Well, you do it through a series of mandatory tests. And look, these checks aren't just about ticking a box for compliance. They are the absolute final step in making sure people and property are safe. Okay, so these tests get split into two really crucial categories. First up, we've got what we call dead tests. As the name suggests, we do these with the power completely off to make sure the physical wiring is correct and sound. Then, only then, come the live tests. That's when we energize the installation to make sure all the safety systems kick in exactly like they're supposed to. Let's start with the checks you do before a single volt is flowing. Right, first up, the dead tests. With everything safely de-energized, we're basically checking the bones of the installation. This is our fundamental first line of defense. The earth continuity test, think of this as building a safety net. What it does is confirm that if a fault happens, say a live wire touches a metal casing, that jolt of electricity has a super easy, low-resistance path straight to the ground. That's what allows the circuit breaker to trip in a fraction of a second. So how's it done? You grab a continuity tester and you literally test the connection from the main earth bar in the switchboard out to every single bit of exposed metal you could possibly touch. We're talking light fittings, the switchboard enclosure itself, even a metal fence post if it's part of the installation. And here's the magic number. The whole point is we are looking for a very, very low resistance. A good solid connection is typically less than 1 ohm. That tells us our safety path is clear and ready to do its job if things go wrong. Okay, next up is the polarity test. Now, this sounds pretty basic, but it is so important. This is all about making sure the live wire, the active, is the one being switched, and that the neutral and earth wires are right where they're supposed to be and not mixed up. So, what happens if you get this wrong? I mean, this is a classic but incredibly dangerous mistake. What if the switch is on the neutral wire instead of the active? What do you think happens? Well, you flick the switch, the light goes out, the appliance seems to be off, but inside, its guts are still completely live, just sitting there, waiting for someone to touch them. Correct polarity makes sure that when a switch says off, it means off, totally de-energized. It prevents a really nasty and potentially deadly surprise.
Let's move on to the insulation resistance test. The best way to think about this is like pressure testing the wiring. We're making sure that the plastic insulation on the cables hasn't been nicked, cut, or damaged, which could cause electricity to leak out.
For this test, you've got to disconnect any sensitive electronics first. Then you apply a 500-volt DC charge between every combination of conductors, active to neutral, active to earth, and neutral to earth. You're looking for any weakness or breakdown in that insulation. And according to the AS/NZS 3000 standard, the result you absolutely have to see is at least 1 mega ohm. That's 1 million ohms of resistance. If it's anything less, you've got a problem with that cable insulation that has to be found and fixed. So, once all our dead tests pass, we know the wiring is put together correctly and it's properly insulated. Now, and only now, can we safely flick the switch. It's time to check the active dynamic safety systems with our live tests. All right, this is the big one, the fault loop impedance test. This is a critical live test. It confirms that our entire electrical safety net, from the appliance all the way back to the street transformer and back again, has a low enough total resistance to work when it counts. And this diagram shows that journey perfectly. A fault happens, current rushes down the earth wire, it travels to the MEN link in your switchboard, where the earth and neutral are connected, then it shoots back out to the street transformer to complete the loop. This creates this massive surge of current, and that's what trips the breaker instantly. This test measures the total resistance of that entire path. So what's the point of all that? Well, the loop impedance has to be low enough to guarantee that the circuit breaker cuts the power in under 0.4 seconds for final subcircuits, like your power points and lights. That incredible speed is what stops someone from being electrocuted and prevents fires. And finally, while everything's live, we also have to do a quick operational check on any RCDs, or residual current devices. You probably know them as safety switches. These are absolute lifesavers. They're designed to detect tiny, tiny leakages of current as small as 30 milliamps, and they have to trip almost instantly. We test them to make sure they'll operate well within their specified time, which is much, much faster than that 0.4-second mark we just talked about. So, after all that theory, why does this really matter in the real world? Well, let's take a look at where these tests are being done every single day to keep us all safe. Think about it. From the moment a brand new house is wired up and ready for handover, to installing public streetlights for the local council, or even trying to find a tricky fault on a long cable running to a shed out in the country, these tests are the final, non-negotiable sign-off that an installation is safe to use. Okay, let's do a quick recap. Here's how these core tests all work together to create a complete safety system. See, each test covers a different but critical piece of the safety puzzle. Earth continuity protects you from touching live metal. Polarity makes sure your switches actually turn things off. Insulation resistance guarantees your cables are healthy. And the fault loop impedance test ensures that if all else fails, the power is cut in a flash. And that really is the ultimate takeaway here. These tests aren't just a bunch of rules in a book. They are the fundamental hands-on skills that protect property and, most importantly, protect people's lives. Master them, and you make sure every job you do is not just compliant, but genuinely safe. Hey, thanks so much for your time, and please keep watching these interesting videos. And, of course, like, share, and subscribe to the channel.